Hi, everybody. Hope everything went well yesterday. I heard from a few people via email about getting online or really small questions, and I just want to make sure that everyone is where we need to be at this point. I will have office hours today from 10 to 11 again. I am also going to post not just the Google Meet site so you could do audio video, but if that's not working for you, mine's a little shoddy myself. There's also a call-in number, so I might do that because my Wi-Fi is not so great here for some reason. I'm trying to get it converted, but I'm gonna have to do it over the weekend. In any case, I wanted to talk to you all about the homework and go over a few of the homework questions that I know might be important for us to go over. The one thing I want to mention is that this is a building block for the next lesson, which is today. So without a doubt, you have to do lesson 3 in order to do lesson 4. If you get behind it all, not a big deal. Just get it done. Let me know you got it done, and I'll mark you in. I'm going to put in grades sometime today. Grades meaning turned in, nothing else. So let's talk about a few of the questions I wanted to mention. The first one I want to mention, so all the questions on the first page for L3 were just factoring out a greatest common factor and then writing what's left over. So we've done these already in class, so I think this would have been relatively straightforward for everybody. I'm looking through a few of them, so let me talk about a few of them that I want to point out. The first one is, let's talk about J. So J, so 3J. J, if you notice, it's x to the third and x to the second. We definitely want to make sure that we're getting this x to the second. Let me see if I can do this. This x to the second out. So the greatest common factor is 15 x to the second. The thing with all of these is lots of them have a common factor. 5, 2 oftentimes is a lot of them. Looking through real quick, like K, 2 comes out. Lots of other numbers do too. 4 comes out, but you want to look for the greatest common factor. So in each of these, you want to make sure you pull out the greatest common factor, because when we move on to the rest of this unit, we're going to need to have it completely factored as much as possible, as much as you can, and then you're done. Let's talk about K for a moment. You had 2 options to do here. They actually pulled out 16T. My personal preference, I mentioned it in class before last week, was that I really want to have what's in the parentheses to be start with a positive number. So I'm actually going to, let me erase this. I'm actually going to suggest instead that we do negative 16t, and what am I left with? T minus 6. It's not the end of the world if you did it the way that Kirk did it. However, what I want to point out is I want eventually for that number in parentheses, the very first number, in this case t, to be positive. Why? Because when we move forward in these lessons in the rest of Unit 7 and Unit 8, I need that first number to be positive. And it's usually going to be t or t squared or whatever the number is, okay? So that's what I wanted to mention on the first page. Any other questions you have, either email me or ask me during my office hours between 10 and 11 today. The second page, it's kind of more of a little bit of a puzzle. They want you to visualize that you can actually pull out a GCF binomial. So in questions A and C, they're both very similar. The greatest common factor is in A plus 5, C is, x plus 5 and x minus 3 for C. But if you notice on B, the issue with B, which makes it more challenging, is that we have this minus right here, the negative minus, and then the rest of it. So yeah, our GCF is still going to be 2x minus 1. But then I have to talk about what's left over. So what's left over? I'm left over with 3x plus 5. But I'm also left over with this distributed negative. So then I'm left with negative x minus 4. You have to do that. You have to distribute that negative. Why is it not going to the 2x minus 1? Because when you have a negative in front of multiple numbers, it can go to any of those numbers. And we know that. If I had, as an example, here's an example, if I had -3 times 6, that negative could be either with a 3 or with 6. You know that. So the same thing goes with a binomial. So instead of a monomial of 3 or 6, I now have a binomial of 2x minus 1. That negative I'm not going to put with it because I'm just going to pull it out, again, put it off to the side, and what am I left over with? 5 is a little more challenging. I wouldn't stress over it. It really doesn't come up on the regions, but I think it's a good puzzle because it's going to help us when we get to more complex questions. 6, they're trying to get us to visualize that if one of the sides of the rectangle, so if one of the sides of the rectangle is, the width is 2x plus 7, what's the length? So what you want to do is you want to look at the original problem and say, okay, how many times does 2x plus 7 go into it? Well, 2x goes into 16x squared. I'll write it down here. 8x times. And how many times does 7 go into, and that's it. We're done. The 7 also goes into it 8x times. So that's how you would do a question like 6. A little more challenging. It feeds off of question 5. Don't stress about it too much. But I could see that type of question being on some sort of regions because it helps you to kind of say, well, what's left over? Otherwise, I think that's it. We're going to be doing lesson 4 today for homework, and we're going to be doing the homework as well. Then we'll take a pause, and I might do a worksheet tomorrow. We'll see. As always, please let me know any questions you have. If you're having difficulties doing anything, whether it's via the computer or just doing the problems, shoot me an email or just talk to me during the office hours. That'd be great. Have a great day, everybody. Bye.